Nice with some sun, eh? Especially when one spends far too much time for their own good YouTube, as I do. So, late one evening, I was doing just that, and I stumbled across the Lazy Geeks review of Tasiq's Strainwave gear mount. Yeah, a budget Strainwave gear mount. It's amazing, and it seemed to work really well for the price tag. Yeah, I was struggling to fight off a shopping basket to get one. That was impressive. Yeah, I don't know what happens. Like all of a sudden, my shopping basket was getting filled with like Strainwave gears and stepper motors and motor drivers, equatorial wedges and dovetail clamps instead. Yeah, I don't know how that happens. It's like either the algorithms got me figured out or someone's been telling on me. Yeah, you know about? No, don't know how that happens. It's like there's this. Oh, there it is again. You hear that? What? If you build it, it will come. All right then. Let's get going. It will come. Yeah. What? I don't know. Right. So we are going to build ourselves a Strainwave gear mount. Yeah. This is 100-to-1 reduction gearboxes. It's 51 Newton meters maximum average torque ratio, which means that they can hold a pretty good weight as an average, like a continuous force, which is what you want. They can do a lot more in like instant torque values, etc. So it's pretty good. This is the main housing. This is a circular spline, and meshing up with this is the flex spline that sits inside here. Yeah. And this is the wave generator, which is basically an elliptical bearing that meshes into the flex spline and pushes the gears from the flex spline into the circular spline, and basically massages the flex spline around and move the output, which I now have connected to this little adapter plate. Basically move this around in the opposite direction as the motor wave generator is moving. Yeah, so, and it's got, well, good teeth contact, and it's continuous connection, so it's got very low backlash. I think they said like less than 20 arc seconds or something, which is quite nice. Yes, and you've got this like motor attachment plate, in this case Nema 17. Sits with a 5mm D-shaped axle. And I got a little servo as an MKR42 servo. So it's basically a magnetic encoder. So I bought this assembled, but you can buy the encoder separately and just get your preference of motor. But it's got a little magnet on this side of the motor axle that comes out the other end here. And the encoder has got a magnetic sensor, basically like a little compass. Senses the field lines coming through it or the direction of them, so it can basically tell you with a 14-bit resolution in this case how the magnet is oriented. And that gives you the ability with this to have like a servo function, like a feedback loop to control exactly where the motor is. It gives you an error of what it's supposed to be. You can set the speed, you can drive it with like a pulse mode, you can drive it in UART, and there is a version that you can get it for CAN control, whichever you like. So the only bad thing about this is that the minimum speed that I could get out of it using the maximum microstep setting and the minimum speed setting, I got it to about one revolution in 90 or 100 seconds. Yeah, and I needed to go one revolution in 14 minutes and 21-ish seconds. So it was way too fast, which means that the speed setting that you can set it for is not slow enough. However, if you use pulse control, you can just step it in whatever speed you need, but that means that you need to have a loop controlling the motion yourself, which is pretty much exactly as I had in the Lucid mount, so I just adapted that software for it. Yeah, you can still read the encoder values, and you can change the step size, etc. on the fly. Anyway, it's not ideal, but it works. So basically, you have these two together. I think these were about just over 100 euros-ish. Motor assembly was about 50 euros with everything included. I got this. It's a dovetail plate, dual clamp down for heavier things. 100 euro, maybe 90, 80 euros, and which ended up kind of small wedge tripod fitting. They said in the on the sell site that it was from 20 plus kilos, but they do recommend no more than 15. That includes the whole head. So, and I mean, it is a bit tiny, so we'll see if I do something else at some point, but we're going to test it with this anyway. I also got a little ESP32, which is my main controller, here in a little case for it, with connectors, USB connectors for the motors. You got one for an Ethernet port, and one for the serial connector that goes to the UART to talk to the motors. Yeah. I also 3D printed, I'll get them in aluminium at some point, adapter plates between the motor and or the gearbox and the wedge adapter, and there's another one between the wedge and the gearbox. Yeah. So the rest is just to build something up to connect all these parts together. The normal thing that you see is basically a little box, like a cube with two gearbox sticking out of them, and then one attaches to a dovetail and one attaches to a wedge. Yeah, and they all look the same. It doesn't matter how much they cost; it's pretty much the same. There's some DIY stuff that looks a bit different, so I thought I'll do the same thing. I want to get something unique, yeah, something that I haven't seen before. So that's what I'm gonna do. Yes, Strainwave gear mount coming up. So, under this top, we have our next creation. Yeah, drum. Here it comes. Look at that. Right. Look at it. Get some more light on it. Yeah. Boxes. Yeah. Boxes with motors sticking out. Nah. We're doing, I don't know what to call this. Yeah. I have no idea. Things comes to mind, but not sure if it's decent, any of it. Yeah, out of focus. And also, there we go. So, here we go. We have our mount. I am using, like, I'm trying to show you what I'm using here. It's a Stellamates app for controlling it. So this is max speed at the moment. So slightly jerky. I have to work on it. But yeah, so that is it. So what I'm going to do now is basically just set it up and then turn the scope a bit so I can get a clear view with the pullmaster, and then you do polar alignments. Yeah. So swing around. About there-ish. Yeah. And then I guess I should also get. I don't know which way is best really. I guess they're gonna turn it all the way around. That perhaps. Yeah. So, good morning, everyone. Yeah, here it is. The Beast. After premiere night, I'm just going to take some shots. So, here we go. It's moving around. Yeah. We're gonna move the telescope a little bit later here and just make a proper pan around and look at things and all that. Yeah. Yeah, so let's give this a lick of paint. Yeah. Make it look all black and shiny. And here it is, laid out in its parts. Let's put it back together, eh? Okay, so assembly time. Partly anyway, we've done some piece, like this piece. So here we have the main mount head. Yeah, 2 gearboxes mounted on a 90-degree stainless steel pipe. So we have the gearboxes with Nema 17 motors and servo drive boards on them, and then we have the controller inside. The outputs is a USB port, 12 volts, and an Ethernet port. And funny enough, you have the Wi-Fi actually penetrating through this, which is amazing enough. But if we are at work or anything else, or if we don't have access to Wi-Fi, we can use the Ethernet port. Yeah. So that's already assembled. So to mount this up on our tripod, then we need to fit the output of the gearbox to the like equatorial wedge and to the dovetail clamp. I made this out of stainless steel, and we're gonna also try to weigh this thing. I might actually try to do that in parts now. I can weigh this on my kitchen scale. So let's see what this is. So this is 3 kilos, 2987, 3 kilos. The wedge is 632 grams. The dovetail clamp is 913 grams. The 2 plates are together, can't use them separately, 334 grams. And then we have a bunch of screws. So the screws then are 64 grams. That's it. So we'll do the sum up here in a bit. So another word about the mount here. So it's about 0.5 Newton meters, the maximum torque value on the motors, and the gearbox output limit is 51 Newton meters. So that since they're 100 to 1, that matches up pretty nicely, yeah. So yeah, that's pretty good. Right. Yeah.
about -7. Nice and crispy everywhere. I think my little pond is frozen. And there's my mount. Oh, the whole brick anyway. Look at that. Covered in frost. Yes, so zoom out a bit. There it is. Huh? Lovely. And that's the little fan contraption that basically just hoses air in there. It doesn't look like it's doing much, but there is no dew or frost on the mirror. Yeah, so I'm just gonna do flats. I think I'm gonna do sky flats. There's nothing up there, so maybe then I'm gonna start picking things up.
So, new mount, yeah. Building mounts, yeah, I love it. So that's it. Strainwave gear mount, yeah. So here it is, the body of our Strainwave gear mount, the one that we just saw. It's right here. So this means that we have moved on. Yeah, it's been evolving a bit, but I thought I have to push this out because otherwise it's getting too long. So anyway, here it is. I love it. Yeah, no square boxes here. Yeah, just a curved, not almost organic. Yeah, super nice. Love it. Anyway, so but before anyone asks, stainless. What the hell? I mean, yeah. Uh, Started with aluminium. Yeah, felt like the obvious choice. It's just that I have my astronomically priced kit on it. Uh, it's been living in danger as it is, but I just felt I want to go something. I want to go safe. Yeah, so stainless welding. Yeah, that is my choice. It works. I might circle back to this later on, but for now, before I have till I have like a solid design that I want to work on, I'm going with this. I mean, this is like 0.8 kilos. This is 0.5 ish. So really, in the grand scheme of things, the total mount head with this was with a wedge and dovetail clamp was about 4.9 ish. So subtract 0.3 kilos. I mean, I'm not bothered. Yeah, it's light as it is. Yeah, so Strainwave gearboxes. Is that the answer to everything? Yeah, just shunk our old CGX mount and all that away, maybe. Yeah. Well, there's no such thing as a free lunch, and they come with pros and cons. Like periodic error is a really obvious one. Yeah. Um, you have to deal with them. Somehow it seems like we've just learned to deal with the periodic error on the worm gear mounts a lot better. Maybe they're easy to predict, or maybe we just have to work on it. For this one, I mean, yeah, you can do like 0.5 or fast guide speeds, like I'm doing 0.5 seconds to 1 second normally. Also, really aggressive guide corrections to deal with it. And I mean, it works, yeah. Declination, really good. Yeah, I mean, it's not really correcting that much. So that between 0.3 to 0.8 arc second normally. Right ascension with a periodic error and some little gremlings, you see like around 1 arc second RMS. Yeah, 1 to 1.5. Sometimes I've had a few nights where I've been below 1 arc second total RMS, and some nights I've been closer to 2 arc second total. So it's a little bit of a work in progress to get things dialed in properly. But yeah, it's a really nice design. There is a few other cons that we'll get into, but we'll do that later on with the Strainwave gearboxes and how they work, and just my design or how I deal with things with the drivers, etc. But we'll do that later. For now, really nice, love it. Yeah, that's it. building mounts. Awesome. So, till next time, may the dark side be with you.